Okay, so I'm feeling a little sick, so I apologize if my voice sounds a little weird and it's hard to hear me, but we'll try and get through it. Today, our lesson is on finding trig ratios and using trig ratios to find side lengths. Trig ratios are something that we can only find if we're using right triangles, and there's three main types of trig ratios. The first type is the sine ratio. The second type is the cosine ratio, and the third type is the tangent ratio. Now, when we're using this in math, we've probably already seen these on our calculator. We don't write the whole word out, we just abbreviate it. Sine, we see as just sine, S-I-N. It's not sin, we still say sine. Cosine is represented by just cos or cos, but again, we still say the word cosine. And tangent is represented by tan or tan. But again, we say the full word tangent. So we have sine, cosine, and tangent. And you can see these buttons on your calculator. So, what are the sine, cosine, and tangent ratios? Right? The sine, cosine, and tangent ratios are all in reference to an angle. So this x is just any angle in the triangle. Right? And that's usually measured in degrees. And then we have our fractions here, because ratios we know are comparing two different things in fraction form. Right? So our sine ratio is comparing the opposite side to the hypotenuse. Okay, and again, just like x is representing angles, our opposite and our hypotenuse are sides of the triangle. Right? Same thing here. X and the cosine will be an angle, and our ratio will be created from sides. But in the cosine, instead of opposite and hypotenuse, we use the adjacent side, and we've talked about this before, but adjacent means touching, and hypotenuse is going to be the denominator. So adjacent over hypotenuse. And again, these are both sides of the triangle. And lastly is the tangent. X is the angle, and the sides or the ratio are created from the opposite side and the adjacent side. Right? So this is a lot to remember. We try and write a nice little shortcut to help us remember all this information, and that shortcut is SOHCAHTOA. This is something you should have written down in your notes, because it is really important, and this is what we're going to be using when we talk about our tangent ratios. SOHCAHTOA. So is sine. S stands for the sine, and O and H are the ratio, opposite hypotenuse. So if you just remember so, you remember the sine ratio. Ka is the cosine ratio. Cosine, which is adjacent over hypotenuse, and TOA is the tangent ratio, opposite over adjacent. So this is just a shortcut for all of this information here. So remember SOHCAHTOA, and you have all of your tangent ratios. So let's use SOHCAHTOA in an example. Here we have a right triangle. We have the right angle, so we know we can use our trig ratios. We have the information 7 is one of the sides and 24 is another side. We want to find the sine of A, meaning we're using A as our reference angle. So for this, we're going to use A as our starting point. Again, we can use our shortcut to kind of help us out. SOHCAHTOA. Okay, so sine lets us know we're going to be working with the opposite and the hypotenuse. So we know we want opposite and hypotenuse. And again, A is telling us that that's our starting point. So we want to use the side that is opposite from A, which is 24, and the hypotenuse, which would be the hypotenuse of the triangle. Now we don't have that information, so we could use our Pythagorean theorem, a squared plus b squared equals c squared, to find that missing information using 7 and 24 to help us find, or we hopefully recognize that 7 and 24 are two of the special numbers from a Pythagorean theorem triple, and without doing any information, we could know that this is 25. So whether you're using Pythagorean theorem or we have a triple, now we know our hypotenuse, which is 25, and the sine of A is 24 over 25. It's that easy. All right, let's try another example. The cosine of A. Again, we're starting with A as our starting point. So we want to do cosine, which now we know is adjacent over hypotenuse using our shortcut. So starting at A, adjacent is the touching side, so 7 over hypotenuse, which we've already found using our triple, 7 over 25, and we're done. There's our cosine ratio. And then finally, the tangent of B. So here we're actually using B as our starting point. And so the tangent ratio, we want the opposite and adjacent. So since we're starting at B, opposite of B is going to be 7, and touching B is going to be 24. So here are just a few quick examples of how we can find our trig using a right triangle and our SOHCAHTOA, our trig ratios. The last example we're going to do is to find the side length using our trig ratios. So here we have a little information. We know that we have a right triangle. We also have a 58, which is not a special right triangle. Here we cannot use 45, 45, 90 or 30, 60, 90. We also can't use the Pythagorean theorem because we only have information on one of these sides. So if we want to find this side, we're forced to use a trig ratio. So I know that I want to use 58 because that's the only angle I have. So if I start with 58, I'm going to have to set up a ratio using the information I'm given. So looking at my shortcuts, SOHCAHTOA, I can determine which of these shortcuts I'm going to use in this problem. All right. I notice that across from my right angle, I don't have any information. I don't have the hypotenuse, so I can't use the sine ratio because that requires that I have the hypotenuse. And I can't use the cosine ratio because that also requires that I have the hypotenuse. And I wrote this wrong. There we go. TOA. The only ratio that I can use is the tangent ratio because I have information about an opposite and adjacent of my 58. So here I'm going to find the tangent of 58. Again, 58 degrees being an angle measure. And I want to find what is the ratio. Well, opposite of 58 is 22. And adjacent to 58 is x. Now I want to solve for x. So I can't solve for x with x being in the numerator, so I'm going to multiply both sides by x, which really this just makes x times this group, and x times x cancels out. So now I have x times the tangent of 58 equal to 22. Since I want to get x by itself, this is x times the tangent of 58. I can divide by the tangent of 58 and divide this side by the tangent of 58. That cancels. So now I have isolated x, which is what I'm trying to find, and I have 22 divided by the tangent of 58. Now, tangent of 58 is just a number, and I have to use my calculator to help me find this. When I put tangent of 58 into my calculator, I get a really long decimal, 1.600334529. So rather than having rounding error, I just want to type into my calculator 22 divided by parentheses tangent, and some calculators will automatically put a parenthesis when you hit the tangent button. So you'll type in 58, hit a parenthesis to close that, and then you'll have to hit another parenthesis to hit your tangent group. When you hit enter, your calculator should give you a decimal 13.747. Since the directions told us to round to the nearest tenth, which is the 7 position, we look at the 4 to see if we need to round, and x will be 13.7 because the 4 will not round it up, which means we found our side length, which was 13.7. Alright, and we didn't need to use the Pythagorean theorem. All we had to know was one angle measure, and using our trig ratio, we were able to solve for that x. Make sure you bring these notes to class so that we can work through some more examples. See you then.